Hi, welcome to study time. Today we are going to study about spectroscopy. Let's see. Spectroscopy, in the broadest sense, is the branch of science that deals with the study of interactions of various type of radiations with matter. The most common form of spectroscopy measure and interpret the absorption or emission of electromagnetic radiation that occurs when the molecules, atoms, or ions of a sample undergo transitions from one allowed energy level to another. Molecular spectroscopy. Depending upon which phenomena is investigated, that is absorption or emission, there are two broad kind of spectroscopic studies, that are absorption spectroscopy and emission spectroscopy. Electromagnetic radiation, EMR. Electromagnetic radiation is a radiant energy that propagated through free space or through a material medium. Electromagnetic radiations are produced by accelerating charged particles. Definition of EMR, that is electromagnetic radiation. EMR is a self-propagating wave of electromagnetic field which consisting of self-sustaining oscillating electric and magnetic fields at right angle to each other and to the direction of propagation. Let's see the characteristics of electromagnetic radiation. First one is they show wave particle dual nature, that is they have properties of both wave motion and a stream of particle, that is photons. Second one, electromagnetic waves are associated with oscillating electric and magnetic fields perpendicular to each other and also to the direction of propagation of energy. Third one is these waves do not require a medium and can move in vacuum. Fourth one, all kind of magnetic radiations travel with the same velocity c in vacuum equal to 3 into 10 raised to 8 meter per second. The fourth one is the frequency of a wave is related to wavelength and velocity of light by the equation nu is equal to c by lambda, where nu is the frequency, c is the velocity and lambda is the wavelength. Or we can write nu is equal to c nu bar. Nu bar is the wave number and nu bar is equal to 1 by lambda. The energy of radiation is related to its frequency, wavelength and wave number by the equation E is equal to h nu, which is equal to hc by nu, which is also we can write hc mu bar, where h is the Planck's constant 6.626 into 10 raised to minus 34 joule second. C is the velocity of light, that is 3 into 10 raised to 8 meter per second. Regions of electromagnetic spectrum. The range of frequency present in light or electromagnetic radiation is known as the electromagnetic spectrum, and the spectrum is divided into various regions. Generally, electromagnetic radiations is classified by decreasing wavelength into radio wave radiation, microwave radiation, infrared radiation, visible radiation, ultraviolet radiation, X radiation and gamma radiation. In this figure, we can see the regions of electromagnetic spectrum. Let's see the general features of spectroscopy. Energy levels in molecules, that are rotational energy levels, vibrational and electronic. We can see rotational energy level, the energy possessed by the molecules by virtue of bodily rotation about an axis passing through its center of gravity. The second energy is the vibrational energy, the energy associated with the periodic displacement of the atoms of the molecule from their equilibrium position. Third one is electronic energy, that is the energy associated with the distribution of the electrons of the molecule in its various energy states. The rotational, vibrational and electronic energies of a molecule are quantized. The electronic, vibrational and the rotational levels of a molecule collectively referred to as molecular energy levels. Before going to the various spectroscopic studies, we should know how the interactions of electromagnetic radiation takes place with matter. So let's see the interaction of electromagnetic radiation with matter. When electromagnetic radiation is incident upon matter, it may be reflected, transmitted, refracted, and scattered or absorbed. Interactions of the molecular system can be either with the electric field component or with the magnetic field component of the radiation. Such an interaction will result in the absorption of radiation of a particular frequency by the system. Absorption of a photon of appropriate frequency and hence of energy may be cause a molecule to undergo a transition from a lower energy state E1 to higher energy state E2, such that E2 minus E1 is equal to delta E, which is equal to h nu. This equation represents the essential condition for a transition between quantized levels, and it is referred to as Bohr condition for spectral transitions. The resulting spectrum is called absorption spectrum. Alternatively, by prior excitation to a higher level, that is E2, the molecule may be made revert or relax to the previous lower level, that is E1, with the consequent emission of radiation of a particular frequency satisfying the Bohr condition. A spectrum can make a record of the particular frequency emitted. The resulting spectrum is called emission spectrum. The absorption spectrum of a species is complementary to its emission spectrum. Therefore, both kind of provides the same kind of information regarding molecular structure. In this figure, the transitions through absorption and emissions of radiation are shown. In this first graph, we can see the arrow is upward, that is absorption is take place, and in the second one, this arrow is downward, that means emission of radiation is taken place. Thank you for watching this video. If you like this video, please like, share and subscribe.